Hi everyone. Today I'm going to introduce you to a library that I was working on for some time now, and I'm very excited about its potential. I'm calling this library Synapse Query Analytics. And before we go further, a little disclaimer here. This library has nothing to do with the official Azure Synapse product group or any affiliation with them. It's a tool or a library that I came up with because it provides me with a value that doesn't exist in the product right now. So what's this value? Let me explain this. Right now, if you have any SQL pool that has hundreds, maybe thousands sometimes, when we have big implementations in your data warehouse, after a while you want to know information about your workload profiles. How many select statement versus like insert or copy statement in your workload. The select statements, are they selecting from certain tables for the last 6 months, for example, and the rest of the database is not used or was not utilized in your workload? Maybe you can use this information to take a decision to move some data into a data lake and use external tables for them. The majority of the workload when you are reading data from the data warehouse will be joining between many, maybe tens of tables together to create a meaningful information for your BI users. Now, what are the commonly joined tables together? So if you are taking a decision to do a distribution based on a column or multiple columns, we need to consider this to make sure that we are doing distribution based on columns with tables that are frequently joined together. With all these use cases that you are reading here, and even in the near future, I'm going to add information about the group by columns, the aggregated columns, and all the stuff. We don't have this information in Synapse right now. In Synapse, we are not keep, like the product itself does not keep information about the index usage. If you're coming from a SQL Server background, there is an index usage DMV that gives you information about how your indexes are used. Very good information in the SQL Server. However, in Synapse SQL pools, that does not exist, and that's why I built this library. So let's go and see this library and how the library is working. I'm going to start with the architecture first. I want to go through the overall architecture. I'm going to start with the first one, which is the SQL parser. So the SQL parser is a .NET library, and I implemented this .NET library and deployed it in NuGet. This is important because later we'll see as we use it, we will be using it using Synapse Spark Notebook, and we can reference this library directly, so you don't have to build anything else. This library can be used according to the current architecture, and it can be used in different ways, but it can be used currently using a REST API. So I deployed it as an Azure Function REST API. We still reference the same library. The solution has a console application as well. If you'd like to test it before you deploy anything, you can test it with a console application. And since it's deployed to NuGet, then you can add it to your application, any type of applications as you see fit. So this is the parser. Now, how can we get the queries to parse? How can we get a history of the queries coming to the Synapse? Well, in this case, I have deployment for both things, which is the in diagnostic settings, you can save your diagnostic logs, which contains the queries, to a blob storage. Very cheap, and it keeps everything for a long time. However, it has a limitation that the diagnostic logs will remove any literals from the queries. So any string that you have in the query, any literals would be removed. So something like a copy statement, and you are copying from a URL. This URL does not exist. Anything that is between single quotes in your queries will be removed for security reasons. But that created a limitation for the queries I'm collecting. And also, there is no aggregation in the diagnostic logs. Every time there is a query, it has a new entry. So the amount of data that we have to parse will be too much. On the other hand, we have the query store. The query store I like the implementation of it because it already give me aggregated view of the queries. So it gets me the query, and it gets me as well how many times this query executed and the execution time and information about this. So this is, I see it's more beneficial for such use case, and that's why on GitHub I have the Query Store implementation. However, I have this already tested, but I'm not gonna put it on GitHub for now. So we are collecting data from the Query Store, and I have pipeline as well. The pipeline is not included in the GitHub. It can be like easily created, which loads the data incrementally from Query Store into a table, a permanent table in the SQL pool. Now, this implementation has one side effect, which is permanent tables in SQL pools, they don't support invarchar max. And the Query Store queries are invarchar max. I had to truncate them to be 4,000 characters. But that might be, in many cases, a limiting factor for you. So, and that's why I didn't put the pipeline, because this implementation can be changed. I would highly recommend, if you are implementing this, instead of saving the data into a SQL pool, save the data into a SQL DB. Make a small SQL DB, the smallest size. You don't need to have a large one, and load the data incrementally from the Query Store. And I added the query that I'm depending on from the Query Store into a SQL DB. And then from the SQL DB, that comes the second part. Whether you save data in SQL DB or whether you save data into the SQL pool, anyways, you have the data saved in a table. Then you read the data using a Spark notebook. And then this Spark notebook, I'm using two implementation actually. One Spark notebook, and I'm putting both on GitHub. One Spark notebook is using REST calls, so it calls the REST APIs. I'm using a fantastic library from the Synapse team. It's called Synapse ML. So Synapse ML has a way to call any HTTP endpoint for your data frame. So you have a data frame with thousands of records. You want to call an HTTP endpoint for each record and pass a certain column. Then this is done easily in this case. So I'm doing this, and I'm having the implementation calling the REST API. I'm going to show it to you in a moment. The second one is in the case, because some customers would say, no, I don't want to deploy an Azure Function or any REST API. I'm doing data warehouses, and I want to keep everything in my data warehouse. In this case, I have the second implementation that does everything inside the Synapse Spark, because we are referencing the NuGet package. I wrote this one using the Spark.net, so it's written in C#. Spark, very interesting experience I had to go through to write this. With this architecture, let's move to the GitHub back again to see how the implementation is done. Okay, so this is the URL, and I'm going to put it in the description of the video, and at the same time this video will be referenced in the GitHub README file. I called it SQL parser. At the beginning I didn't know that it would be that big. So in the SQL parser solution, I have SQL parser solution, I have three projects. The query parser kernel, this is the .NET library, and I have here the Synapse visitor. It's a visitor class inherited from the tsql concrete fragment visitor, and this is coming from a library built by the SQL Server team. So this is an official library from the SQL Server team. It's called the SQL, like the namespace is SQL DOM. And this is from the DAGFX library. You can download it separately, or you can get it from NuGet as well. Once you load the solution, you will resolve everything from NuGet. So I'm searching for certain information in the query, not everything. So here I'm starting the processes, and I'm looking for joins. So any select statement that has a join, I'm looking for these joins, and I'm getting all the information about the joins, all the joins table and joins columns. And the second one is copy statement. If you like tested this in the Azure function and you pasted any copy statement, will get you information about copying to which table and copying from which URL. However, in the current implementation of the query store, copy statements, they are not saved in the query store. Hopefully this will be changed soon in the next generation of the query store in Synapse. But I kept it there because I see it's important. And then I have another one for select statements, any select statement, even if it's not join. And the other one for insert statements. I'm going to get information about insert bulk statements, delete statements. And these are helping functions I'm using for the rest. The second project is an Azure function. In my Azure function, I have one function here, and I will show you this function running in a demo. But the idea is I'm getting the query, so I'm getting one query at a time, and I'm parsing it using the library that we just explained. And also I'm saving the information of the request and the response both in storage tables. So I'm using here the SDK for storage tables, and I'm doing this to get like feedback about the queries, and of course if you would like to implement this without this functionality, you can remove this code. But in my original functionality, I'm doing this to make sure that I'm keeping track of how the Azure function is used. With this, let's go to the demo for this part at least. So this is the Azure function, and let's do a demo. I already, like it has a key, and I already authorized. It's already published for testing. And let's try this. If we have a simple query like this one, execute. And we see here the output. So I'm returning back the SQL command. I'm getting information about a select statement, is insert statement, and so on and so forth. And you can see it's select statement, and the select statement from, we are selecting from this table. This is a very simple one. Let's go for a complicated query. Something like this. Okay. So the SQL command, the joined tables, and I have joins between 4 tables, the joined columns, and I'm handling all the aliases if there is aliases, the joined columns, and getting all the joined columns that we joined on, and here as well I'm getting the select statement, so this information would be recorded as well as a column and would be used for filters. If we are having a statement that has comments, so something like this, has 2 comments, has comment here, multi-line comment, and then 1-line comment here at the end of this line. When I execute, there you go, I get the same information from this one. Last test. In this one, I'm going to use a copy statement. So this is the statement, and here is copy statement true, and the copy statement from, and I have here my URL, copy statement into, I have it here, and I'm always returning back the hash of my query for reference. All the queries that I just used right now, every time I'm requesting something, it is saved in a storage table. So if someone, like I'm testing it with different teams, if someone sends something to this REST API and like the result is not accurate, so they can give me the hash and I can search for it, and I will use this to improve the code base. So this is the REST API. Now, I showed you before in the architecture that we are reading the data from the query store and then using notebooks and call either the REST API or embed the library directly in a Synapse notebook. So let's see this part. First implementation, I'm going to show you how we are doing this using a notebook that is calling the REST API. So as I told you, I'm using the Synapse ML, and Synapse ML require these configurations. And then I'm using here, you put the API key, because I'm using keys for authentication. And then this is the table that I have in my SQL pool. It's called Query Store, Query Text. This is a table that I made it up. Like I'm loading the data from the Query Store using pipeline into this this table. You can load it in any table. You can use, even as I explained before, a SQL DB will be more accurate, especially if your queries tend to be more than 4,000 records, because the limitation in the data types for Synapse. So in this case, the table, you are loading it into a data frame and then doing some engineering. This is the core of it. So this is where I'm calling my API, and this is already published, providing the headers and body, and I'm just passing whatever in the column that's called command to the request, and then getting the result, and finally doing some engineering as well to remove any empty arrays and put nulls instead. And finally, I'm having this saving it to two tables. So Synapse SQL Analytics, this is saved as a Spark table, so I can use it from the serverless pools without even using my dedicated SQL pool. So if my dedicated SQL pools are not running 24/7 and I'm having some like pause time where I'm not running them, I can always get my analytics because I'm saving the data in a Spark table that is accessible from either Spark or serverless pool. So I have this one that has all the successful ones. If the query has any errors, I'm saving it in the another table to review it as well. A second implementation, so you can use this way or that way, which is in the second implementation, I'm not calling API. There is no API used at all. I'm referencing the NuGet package for the Microsoft.SQL Server.DECFX. This is the library that my library depends on, referencing the Newtonsoft JSON, and this is my library, Synapse Query Parser kernel. So this is published in NuGet under this name. Now again, loading the data from the table, and this is the query here I'm using. So I'm loading the data from the query store using this query, save it into a table, and then load the data from this table into a Spark data frame. And then what I'm doing after is I'm building a Spark UDF or user-defined function, because I wanna utilize my whole Spark cluster. As you know, this can be done on a smallest size of clusters in Synapse, which is 3 nodes. but I want to utilize the 3 nodes, not only the driver. So if you have lots of records, you will not be needing a larger cluster. So this is how we are creating the UDF. Again, everything here in Spark.net, so everything in C#, because I have to depend on this library. I'm calling my library, so I have a data model here called Synapse Query Model, and the library itself, the main class is called the Synapse Visitor. So I'm calling it, and then I'm processing the command and returning the response back after serializing it in JSON. So that's how I would use my function. I'm adding a new column called SQL Analytics, and then parse SQL, and I'm passing the SQL, the column that's called command here. Extracting the schema. So after I'm getting the data, I'm extracting the schema, and every field will be a column by itself. So every field in the JSON will be a column by itself. And then finally, I'm doing some engineering to remove all the empty arrays and replace them with null. Do the same thing and save the information into the Synapse SQL Analytics table and Synapse SQL Analytics errors table. Okay, so this should be happening, let's say, every day, loading all the new records from the query store, process them, and then parse them and get analytics about them. And then after that, we will save them into this Spark table, and will be ready now to be consumed by your DBAs or data warehouse admins. So let's see an example of the queries that a DBA can get from this table that we saved here. All right, so I have here sample queries, and the first one, and as you can see, I'm using the built-in pool because it's a serverless. So I'm getting the top 100 records from my Synapse SQL Analytics. And voila, I'm getting the information. So I'm getting here, this is the command, the copy statement, every single field is a column. And I'm even keeping the raw result, the JSON result that I'm getting from the library as well in a field called SQL Analytics. So this is the schema, and as you can see, I'm getting information from the query store, like the query ID, so you can get back to more details for the query, last execution, and count execution. So this is important because the queries that are frequently sent to my SQL pool, I need to pay more attention to them because that will affect the user more. All these fields are the fields returning from the library. Join columns, join tables, SQL command, and select statement. Okay, so let's get information about how many insert, select, and delete in my pool. So I have a small pool. I'm not using it much. It's not production. In this data set, I have 62 select and 1 insert. So let's see the select. So in the select, we are filtering by a select statement true, and I'm getting all the select statements here. Okay, how about I want to get information about the details of my select statements. I'm going to highlight the joined. So I want to get only the statements that has joined. So I'm getting where the join table is not null. So I'm getting the same information. Now I can group on this, and I can see the most frequent join table together, because that will impact my decisions for the distributions as well, right? So when I run, here you go, 10 times, that was like a system query. 6 times I have these tables, 5 times I have these tables, 3 times I have these tables, and so on and so forth. So now I know what are the commonly used tables in my workload. Okay. With this, I'd like to thank you for watching the video so far. I'm very excited about this library. Please give me feedback on the GitHub repo. You can go ahead and create issues, like fork it and create pull requests if there is improvement that you can use as well, and contact me for any help about it. Thank you.